Welcome to Pre-Calculus Trig, Section 3.3, Part 2 on the sum and difference formulas. We're going to do a few more examples here. So it says rewrite the sine of x plus 5 pi over 6 in terms of sine of x and cosine of x using a sum or difference formula. So I've got sine of x plus 5 pi over 6. So this is sine with a plus. So I retrieved my sine with a plus formula and I wrote it down. So now I'm going to do some substitutions. So I'm going to say my sine of x plus 5 pi over 6. So I've got a u here and a v here. So I'm going to substitute x for u. So there's a u, and then 5 pi over 6 for v in my formula. Okay, so I've done my substitutions. Now I'm going to notice that 5 pi over 6 is one of my angles on the unit circle. So in the second quadrant, 5 pi over 6, so we've got a negative square root of 3 over 2 would be my cosine, and 1/2 would be my sine. So now I can do some more substituting here. So I don't know what x is, so I have to call that just x. So x is still x. So the cosine of 5 pi over 6 is negative square root of 3 over 2. All right, and I don't know what the cosine of x is, so I just have to leave it the cosine of x. However, the sine of 5 pi over 6 is 1/2, so I can make that substitution here. All right, now let's just neaten this up a little bit. We'll put the negative square root of 3 over 2 in the front, and then the 1/2 times the cosine of x. So this form works. And another way that you could write this is, notice that they both have a 2 as a denominator. You could call this by this name as well, and that would be an equivalent form. So either way, this is what we want. So example 8 says, rewrite the tangent of 3 pi over 2 minus x in terms of a single trig function by using a sum or difference formula. So from my formula sheet, I wrote down my tan with a minus formula. So u is going to be 3 pi over 2, and x is going to be v. So I'm going to substitute in the formula now. So the next thing I'm going to do is I'm going to figure out what the tangent of 3 pi over 2 is. So 3 pi over 2 has a cosine of 0 and a sine of negative 1. So the tangent is equal to the sine over the cosine. So we're negative 1 divided by 0. So that's undefined. All right, so I can't use this form in order to simplify tangent of 3 pi over 2 minus x if I have an undefined situation here and here. So I have to take a different route when this shows up. So this is the approach we're going to take. We're going to evaluate the sine of 3 pi over 2 minus x and then the cosine of 3 pi over 2 minus x. This will work because sine we can figure out and cosine we can figure out in the formulas. All right, so let's go ahead and set the formulas up. Okay, so I wrote out the formula here. Sine of with a minus divided by cosine with the minus. Now I'm going to substitute in for u, 3 pi over 2, and for v, x, in this whole formula here. All right, did my substitutions here. So now let's think about the unit circle again. So we had that drawing down here. So cosine 0 and sine negative 1. So that's going to allow some things to go to 0 and drop out for us. So wherever we have a cosine of 3 pi over 2, that part is going to drop out. All right, so those go to 0 right there because the cosine of 3 pi over 2 is 0. All right, so that simplifies it a little bit. So now we've got in the numerator sine of 3 pi over 2 cosine of x. That's all we have left. And in the denominator, sine of 3 pi over 2 sine of x. All right, so sine of 3 pi over 2 is minus 1. So I'm going to substitute minus 1. All right, so those are going to cancel out. So we're just left with cosine of x over the sine of x, and we know that is the cotangent of x. So that all simplifies to the cotangent of x. And we were able to figure that out by using this setup right here in green. In example 9, we're asked to rewrite the cosecant of pi minus x in terms of a single trig function by using a sum or difference formula. So we don't have a formula for the cosecant of pi minus x, so we write it as 1 over the sine of pi minus x. All right, so I need to find the sine with a minus formula. So I'm going to do that, and I'm going to write it down. So I got my formula, sine of u minus v, so I have 1 over the formula here. All right, so now I'm talking about u being pi and v being x. So I've got 1 over the sine of pi minus x. Let's just write that. So that's 1 over the sine of pi cosine of x minus cosine of pi sine of x. All right, so I've got the sign correct. You always want to be very careful you don't mess up your substitutions before you take the next step. All right, so the next step is to figure out what the sine and the cosine of pi are. So here's pi over here. So the cosine is negative 1 and the sine is 0. So something is going to drop out. So I'll just write it out. The sine of pi is 0, and the cosine of x is just the cosine of x. The cosine of pi is negative 1, and the sine of x is just sine of x. So I drop out right here. So I'm left with 1 over 2 negatives is a positive, so 1 over the sine of x. So that's equal to the cosecant of x. So that all reduces to the cosecant of x. So you might wonder if this is something that's always going to be the case, because if we started out with the cosecant, you're always going to end up with the cosecant. No, that was just a coincidence of the fact that we were working with pi here. All right, so it really is not always going to be the cosecant of x. You have to work through the problem. So this one says solve the equation, and here's this long equation here, equals to 0.61 for the smallest positive solution. So this is an application of the sign and sum and difference formulas to solving an equation. So what you want to do is notice the setup here, sine, cosine, minus cosine, sine, where we have u, v, v, that kind of setup. This is actually, if I go back and look at my formula page, so this is actually the sine of u minus v. Sine u cosine v minus cosine u sine v. So I've really got the sine of u minus v, which is how I want to write it. So this is going to be u, and this is v. So this is really the sine of 2x. So that's my u minus v 5x is equal to 0.61. So now let's combine those two. So I have the sine of negative 3x is equal to 0.61. All right, so I've got that negative inside the parentheses there, so I can utilize my other identities that we talked about earlier. So let's go back to that page. So on this page, I know that the sine of a negative angle is equal to the negative of sine of the positive angle. All right, so I can rewrite that sine of negative 3x as negative sine of 3x. So let's do that next. So I just wrote this over on the side here, so make a note of that in your notes. So I'm going to replace sine of 3x, of negative 3x, with negative sine of 3x. All right, so then I'm going to divide out that negative, and I'll have isolated my sine of 3x. All right, so now I'm going to take the inverse sine of both sides, so I can get to the 3x. This is not one of my unit circle angles, so I'm going to have to use the calculator here. So if I plug that into the calculator, what I get is 3x is equal to negative 0.65606 radians. Okay, so remember when we do an inverse sine, it gives you an angle between negative pi over 2 and pi over 2. So it's given me this angle here. So that's negative 0.65606 radians. So that's a negative angle there. Okay, so if my sine is negative 0.61, that means I also am going to have another negative 0.61 over here in the third quadrant, okay, because they have the same sign right there. So I'm also going to have, by the symmetry of the problem, that 0.65606 amount right there as well. All right. So that gives me my two angles. Of course, we don't want to call them negative angles. We want to call them positive angles. So I've got two positive angles here. So I've got one right here. We'll make that one green. And I've got one right here. Make that one red. All right, so it wanted the smaller angle, so that means it wants that green angle. All right, so I'm going to say 3x is equal to, so if I want to figure out what that green angle is, I've got pi radians to here, and then I've got this piece, which is 0.65606 radians, so I got to add those together. Pi plus 0.65606 radians. So if I type that in the calculator, I'll get 3x is equal to 3.79765 radians. All right, so the last step then will be to divide by 3 so I can find the angle x, which is our solution. So if I divide that by 3, I get 1.2659 radians. And this will be my smallest positive solution. All right, I wouldn't pick the red one because that's going to be a larger angle. It's got more rotation. All right, so this is my solution right here. All right, so this one says write the cosine of 25 times the cosine of 6 minus the sine of 25 times the sine of 6 as a trig function of one angle in radians. So let's see. So if we have cosine minus sine, and this is u and this is v, let's go back to our formula page, and we can see that that's going to be the cosine of u plus v. So I need this formula here to help me simplify this problem. So I wrote it all out. So I've got the cosine of u plus v, so u is 25, v is 6, so you can see this matches up right here. So what this is simply this, which is the cosine of 31 degrees. So according to our instructions, what we're asked to do is not leave it in degrees, basically. We want the angle to be in radians. All right, so remember when we convert from degrees to radians, we got to multiply by pi over 180. So cosine of 31, written in radians, I'm going to multiply it by pi over 180. See, so the degrees cancel. All right, so the degrees are going to cancel. So I'll have the cosine of 31 pi, it doesn't reduce any better than this, over 180. Okay, so this is what we wanted in radians. All right, so we've done what the problem statement asked us to do. Write it as a trig function of one angle. Okay, that's one angle, and it's in radians. So we're done with this one. So these formulas are helpful at taking something like this and condensing it down to something like this. All right, so another type of problem here. Given two angles, phi and theta, where phi is in the first quadrant, theta is in the second quadrant. Also, the tangent of theta is negative 7 over 3, and the cotangent of phi is 11 over 2. Find the sine of theta minus phi. All right, so let's break down the information. So we need to draw a diagram to help us with these kind of problems. All right, so we've got two angles. Phi is in the first quadrant, so this will be phi over here. And then theta is in the second quadrant. So here's the second quadrant. Theta is right there. All right, so now I'm going to drop a perpendicular for both of these angles. So phi and theta. And I'm going to put my numbers on them. So my numbers are given to me in terms of trig functions. So the information about theta is that your tangent is equal to negative 7 over 3. So tangent is equal to the sine of theta over the cosine of theta. So that means sine must be negative 7. Actually, that's not going to work. The negative must go down, so you have to figure that out. So the negative can't be on the sine in the second quadrant. It's going to have to be on the cosine. All right, so the negative 3 is going to go on the adjacent side, and the 7 is going to go over here on the opposite side. All right, so we don't know what this side is yet. We're going to have to figure it out. All right, so now for phi, I'm given phi's sides in terms of a cotangent, so that's 11 over 2. So cotangent is cosine over sine. All right, so they're both positive in the first quadrant. So the cosine, that's my x value, is 11, and my sine is 2. So we have to figure out what r is. All right, so what we're asked for is to find the sine of theta minus phi. All right, so we need a formula for that. So we got to go back to the formula sheet. So we would have to use the sine with a minus formula. So that would be this one here. So we're going to write that down. Okay, so I've got my formula written down. Now let's put in the phi and the theta where they go. All right, so I got everything in there now. So now we have to figure out what the values for these four trig functions right here are. And to do that, we need to know what these r values are right here. So let's use the Pythagorean theorem next. So for theta, I'm going to have negative 3 squared plus 7 squared. So that's 9 plus 49. So that's 58. So we've got the square root of 58. All right, so the square root of 58, let's see if that reduces. 2 times 29. So we're just going to leave at the square root of 58. So I wrote it on my diagram, square root of 58. Now we got to figure out r for my phi triangle. So I have 11 squared plus 2 squared. 121 plus 4, that's 125. So the square root of 125, so that's 5 root 5. So I'm going to put that on my triangle. Okay, so I have all my numbers. So let's substitute into the formula now. So I've got the sine of theta first. So that's going to be 7 over root 58. And then the cosine of phi, so that's 11 over 5 root 5. And then I've got the cosine of theta, so that's negative 3 over root 58. And then the sine of phi, which would be 2 opposite over 5 root 5. All right, so we're going to simplify this now. So on the top I have 77 divided by 5 root 5 root 58. Let's just leave it like that for a minute. So I've got 2 negatives, so this is going to be plus 3 times 2 is 6. 5 root 5 root 58. All right, 77 plus 6. So let's move it up a little bit. So that's 83 divided by 5 on the outside. So this is the common denominator. So underneath the radical, let's just multiply 5 times 58. So that's 290. All right, so generally we want to go ahead and rationalize the denominator here. So let's do that. So I have 83 times the square root of 290 divided by 5. So square root of 290 times the square root of 290 is 290. All right. So you want to see whether you can reduce 83 divided by 5 times 290, but that doesn't look like it's going to reduce. 83 is a prime number, and 290 is 29 times 5 times 2, so nothing's going to cancel out here. So we're just going to have to leave it with those crazy numbers. So I typed it into my calculator, 5 times 290, so that gave me 1450. So this right here is the sine of theta minus phi. So this is the last problem we're going to do here. So these are fun. They have a lot of details. So let's do some highlighting here. So given two angles alpha and beta, where alpha is in the first quadrant, so we know that. Beta is in the fourth quadrant. So I'm going to do each of these in a different color so we can keep it straight. Cosine of alpha is square root of 3 over 7. And let's see what else. Cosine of alpha is square root of 3 over 7. Sine of beta is negative square root of 2 over 5. And then what we're asked to do is find the tangent of alpha plus beta. All right, so if we're supposed to find the tangent of alpha plus beta, that means we need the tangent formula with a plus. So let's get that off the formula sheet and write it down. So there's our formula. So we have two angles, alpha and beta. So let's make alpha u and beta v. So plugging alpha and beta into our formula. So there we have it. So we're looking to find out what the tangent of alpha and the tangent of beta are so that we can plug them into our formula. So we want to be able to draw a nice diagram here. So the first piece of information I have is that alpha is in the first quadrant. So I'm going to draw the terminal side of alpha in the first quadrant. So dropping a perpendicular, here's my reference angle alpha. All right, so that's alpha. And then we're also told that beta is in the fourth quadrant. So beta, let's draw the terminal sign for beta. So I'm just drawing a random terminal side there. It may not be the right size, relatively speaking, but I'm just going to draw it anyway. So this right here is beta. All right, and this is alpha. Okay, so now let's put the numbers on there. So our numbers are given to us in terms of a side ratio. So the cosine of alpha is root 3 over 7. Root 3 over 7. So that must mean that root 3 is my adjacent side, and 7 is my hypotenuse. So that would be x over r. All right, so I'm going to put my square root of 3 on my x side and my 7 on my hypotenuse side for the angle alpha. All right, and then for the angle beta, I'm told that the sine of beta is negative root 2 over 5. So that means that this is my opposite side over my hypotenuse. So that's my y over my r. So my r is 5 for the angle beta, and my opposite side is negative root 2. All right, so in order to find the tangent, we need both the opposite and the adjacent side for both alpha and beta. So let's find the opposite side for alpha first. So using Pythagorean theorem, that would be 7 squared minus square root of 3 squared. So that's 49 minus 3, which is 46. So that's 2 and 23. So we're just going to call that square root of 46. All right, so let's figure out the x side for the beta triangle. So that would be 5 squared minus square root of 2 squared. So that's 25 minus 2, which is 23. So square root of 23 is this x side here. All right, so we have everything we need now. So let's write down the tangent of alpha. Let's put it over here. Tangent of alpha is equal to root 46, that's my opposite side, and then root 3, that's my adjacent side. Tangent of beta is equal to negative root 2, that's my opposite side, over root 23, that's my adjacent side. All right, substituting into our formula, we have tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha times tangent of beta All right, so I've got, let's get the sign straightened out here. So this is just a plus minus here, so we can say minus. And then right here I've got minus minus, so we can just say plus there. Just put plus there. All right, so now let's go ahead and find a common denominator here and see if we can neaten this up a little bit. So my common denominator is going to be square root of 3 times square root of 23. So this one needs a square root of 3 to have the same denominator. This one needs a square root of 23. This one needs both. And this one has both of them already. All right, so now we can go ahead and cross out all of the denominators because they're the same now. And I'm left with the numerator. So let's just highlight what we have left. Okay, so what I have left is just that part in pink, which is the numerators. So right here I've got square root of 23 times the square root of 46. So that's the same thing as square root of 23, square root of 23 times square root of 2, because 2 times 23 is 46. All right, so let's go ahead and just go ahead and call this one square root of 6. 2 times 3 is 6. All right, and then I've got square root of, it's 3 times 23 is 69. And then in the last one here, I've got square root of 2, square root of 23 for that multiplies to square root of 46, and then square root of 2. All right, so this one here, this one is here and here. 2 times 3 is 6. 3 times 23 is 69. And then square root of 46 is square root of 2 times square root of 23, square root of 2. All right, so I've got, in this one here, I can take out a 23, so that's 23 square root of 2 minus square root of 6, square root of 69. All right, and here I've got square root of 2 times the square root of 2 is 2, square root of 23. All right, so we're just going to leave it like that because I'm not going to take the time to rationalize the denominator here. All right, so this is okay like this. One other acceptable form, if I go back over to here and I get rid of all of my red markings here. All right, so just ignore those green lines for a minute. You could also write this, oops. So in fraction form, I could say root 46 over 3 minus root 2 over 23, 1 plus, let's see, 2 root 23 over root 3 root 23. All right, so this right here is another form you might see it in. Okay, but I prefer this one here. All right, either one of them, both of these are not rationalized. So that would be more work, but we're just not going to go there right now.